going to talk about complex numbers, we have to know about imaginary numbers. So remember, in an imaginary number, I squared is -1, which means I is the square root of -1. A complex number is just anything of the form a plus bi. We call the a the real part, and b is the imaginary part. So complex numbers have a real part and an imaginary part. And anytime we see I, it is the square root of -1. Are complex numbers? So complex a plus bi, but it doesn't technically have to have both parts. So if it's a real number, it doesn't have an imaginary part. It's just the a part. If it's pure imaginary, there's no real part, so you only have the I term. And then non-real complex has both terms in it. It has the real and the imaginary part. So, real number doesn't have an I. If it's pure imaginary, there's no real term. And non-real complex has both pieces. So if I want you to identify each number as real, pure imaginary, or non-real complex, use all that apply. Can it be more than one of these things? Real only has the real term. Pure imaginary is just the imaginary term. Non-real complex, the definition of it, a plus bi, the b isn't 0. Couldn't the a be 0 with this definition of non-real complex? All I told you was that b couldn't be. So when I look at this first number, 13i, is that a real number? No. Is it pure imaginary? Does it have only the imaginary term? Yes, because I'm not adding any real part to it. Okay, then looking at our definition, non-real complex, a plus bi, it tells me b can't be 0. It doesn't say anything about a. Isn't this the same as 0 plus 13i? So by that definition, this is also the non-real complex. So if it's pure imaginary, it also falls into the non-real complex umbrella.
So we have to put both of those?
Yes. All right, if we look at the second one. Okay, is that a real number? No. Okay, is it pure imaginary? Pure imaginary requires that we only have the imaginary term. Does that describe this? No. So what's this one going to be? Okay, if I give you pi, pi is just a number. Does it have an I with it? No, so it's not imaginary. What is this?
Real. It's in a 3.14.
Mm-hmm.
does 3.14 get its own?
Because it doesn't really stop at 3.14. It keeps going forever. It's an irrational number. The decimal keeps continuing. So that's why we have a symbol instead of rounding everything to
So, but
3.1.
why does it specifically get?
So it's actually a special case. Pi is, if you think about a circle, it's the ratio of circumference to diameter. If you take the distance around the outside of a circle and divide it by the length across the circle, you get that number. So it actually comes up frequently.
So it's an important.
Yes. And that's why that particular one has its own special symbol. Any other questions? All right, any questions about classifying these? Do we need to go through any more? All right, let's talk about reducing radicals.
So that means if you know one, either the parameter or the distance, you can figure out.
You get the other one, yep. If I ask you for the square root of -1, what is the square root of -1? I. That's the definition of what I is. So anytime we have a negative under a square root, it will give us an I. If I say the square root of -8, okay, you can't do that on your calculator. If it types it in, it's just going to tell you domain error. Because of the negative, what am I going to have in my answer? An I. How can I break down 8 using radicals? 8 is 4 times 2, the square root of 4 is 2, and we still have a square root of 2. Technically, it doesn't matter if you put where the I goes. You know, sometimes some textbooks say 2 radical 2I. I think Mrs. Keller had you put it in front of the radical so you didn't accidentally leave it under the square root, so I try to follow that notation. All right. If you are going to be multiplying with negative radicands, so when you have negatives under the radical, you have to take out the I before you multiply them together, which kind of goes against maybe what we might initially think. If I'm just looking at this, we know if they're under a square root, we can multiply them. -4 times -9 is 36. But this is not the same thing as the square root of 36, because if I broke down those radicals first, what's the square root of -4? 2I. What's the square root of -9? When you multiply those, you get 6. I times I would be, what's I squared equal to? And the answer is -6. If you don't pull out those i's, you would get a +6. So just anytime we're multiplying, make sure you simplify those radicals, pulling out the negatives before you multiply them together. So let's do some problems. All right. So if I have the square root of -6, what do I need to do? Take the negative out, so it becomes an I can't do the square root of 6, so I'll do it. Square root of -10. Okay. So now we can multiply them together. Numbers outside the radicals get multiplied, so I times I is I squared. Numbers under the radicals get multiplied, so 6 times 10 is 60. I squared is, okay, I want my radicals in lowest form. How can I break down 60? The perfect square, isn't it? and 60. 4. 4 and 15. Square root of 4 is 2. I can't do the square root of 15. So my answer is negative 2 radical 15. Alright, B. If I'm dividing, what should I do first?
Figure out the I.
So that would be I radical 20 over I radical 2. What happens if you're dividing those i's? They cancel. When we were multiplying, if both numbers were under a radical, we could just multiply, and the same is true for dividing. Since both of these are under a square root, we can just divide it. 20 divided by 2 is 10. So we get the square root of 10, and that doesn't reduce. I want you guys to try a couple. So if you take out the i's first, you have I radical 7 times I radical 7. Multiply I times I is I squared. Under the radical, 7 times 7 is 49. I squared is negative 1. Square root of 49 is 7, so we get negative 7. Everybody get that one? Alright, D. On the top, you can take out an I. The bottom we don't need to, so we still have the I, it doesn't cancel. These are both under a square root, so we can divide them and leave it under a square root. So 48 divided by 24 is 2, so we get I radical 2. Is that one alright? Do we need more problems like this? Let's keep dealing with these complex numbers and talk about adding and subtracting. When you add and subtract complex numbers, it's just a matter of combining like terms. So nothing is any different here. We're just putting like terms together. So if I look at this, I have 3 plus 5i plus negative 2 plus 3i. Add your like terms. So 3 plus negative 2 is 1 plus 5i plus 3i is 8i. I am going to tell you that your final answer has to be written in standard form. That's the a plus bi form that we wrote down earlier. So like on the Math Excel, if you type in 8i plus 1, it's going to say you're wrong because that's not technically the standard form. We always put the real number plus the imaginary number when we do that. So number 2, what should I do first here? Distribute the negative. We want to subtract, so we distribute our negative through. And then we just combine like terms. So 6 plus negative 3 is 3. 4i and negative 6i is negative 2i. So 3 minus 2i. Any questions there? You guys do this one for me. Like terms, 9 plus negative 3 is 6. Negative 4i plus 6i is 2i, and you have to have it in that order. So a is 6 plus 2i. B distributes our negative, so 11 plus negative 4 gives us 7. 5i plus I is plus 6i. Are we okay with this? All right. Let's talk about multiplying then. If we multiply with these imaginary numbers, what do you think we have to do? FOIL. Same thing we would do if it were x's and not i's. So if I FOIL these, we get 10 plus 35i plus 6i. 3i times 7i is what?
Which is the same as -1, so it'd be -21.
Yes. So if we add like terms, we have a 10, 35i plus 6i is 41i. I squared is -1, so 21 times -1 is -21. Final answer, a plus bi, so we have to do the 10 and the -21, which gives me -11 plus 41i. So anytime you get an I squared, you have to turn that into -1. B. What does it mean if I have something squared?
FOIL it by itself.
I am taking this times itself. So we get 16 plus 12i plus 12i plus 9i squared. Okay, like terms, 12i plus 12i is 24i. 9i squared is, so 16 minus 9 gives me 7 plus 24i. Okay, you guys do those two. Make sure when you get to the homework that you're paying attention. It seems like after we start multiplying, I always have people that even if there's an addition or subtraction, they try to multiply everything. So make sure you're paying attention if all you're doing is adding or subtracting. So if we FOIL, we get 6 plus 8i minus 9i minus 12i squared. That's -i. -12i squared is positive 12. So we get 18 minus I. B, we get -10 minus 15i minus 16i minus 24i squared. So -10 minus 31i. -24i squared is positive 24. So that gives us 14 minus 31i. Are these okay? Alright. We have a little bit left in this section, but I'm actually going to stop here for today. There's a Math Excel assignment open. You don't know how to do all of it yet, but I think you can do 1 through 14 on that. So you start your Math Excel, you've got time to work right now.